This course is for students and professionals with minimal or no prior computing experience or formal training in programming or computer science. It's also for aspiring students who are either going back to school after some time away from academia or professionals who are beginning or advancing a career in information technology. Generally speaking, this course is an excellent introduction for those who want to learn the basics of programming and who have never programmed before. It's also a great refresher for people who have programmed before but who have not used that skill for some time.
This course provides an introduction to the Java language and object-oriented programming, including an in-depth overview of Java syntax and how it differs from a language like Python. Students will learn how to write custom Java classes and methods, how to test their code using test-driven development and unit testing, and how to generate complete and relevant code documentation from inside of Eclipse. Topics include basic data structures like arrays and array lists, and overloading methods. In terms of the workload, this course will take about 5 to 6 hours per week for approximately 3 weeks. In addition to consuming the produced audio and video content, there will be graded programming assignments every week, regular quizzes to assess your comprehension of the course material, and coding exercises to get you comfortable with object-oriented programming concepts using Java.
Hi, my name is Brandon Krakowski, and I'm the instructor for this Programming Languages and Techniques course. For a bit of background, I started out as a musician and then worked in radio broadcasting and audio production. My experience in programming began with Adobe Flash, a tool I used to develop a live web conferencing platform for Big Pharma. I received my master's in computer and information technology from the University of Pennsylvania and worked as a programmer at Penn's School of Design. I then worked as an application developer for Wharton Computing, working with faculty and staff to build technology to advance several student programs. Somewhere in the middle, I started my own company, Bleak LLC, doing programming and freelance application development for a variety of companies. I transitioned into data and analytics and became the research and education director at Wharton Customer Analytics, managing large-scale research projects with students and academic researchers from around the world. And most recently, I became a lecturer at Penn Engineering. A bit more about me: I play bass, I like my dog, and I'm a family man. Welcome to the Java portion of this course. This module provides an introduction to the Java language and object-oriented programming. It includes an overview of Java syntax, in particular, how it differs from a language like Python. Topics will include variables and data types, loops and conditionals, printing to the console, scanning for user input, and code documentation. This module also explains the structure and inner workings of a Java class and teaches you how to define your own custom classes and methods. First, should we forget about Python? In terms of the syntax, yes, mostly. But you should not forget about code reuse, modular programming, test-driven development, good style, or commenting your code. These concepts will remain important and apply to both Python and Java. Java and Python are similar in that they're both object-oriented programming languages. Conceptually, the languages are very similar, but the syntax is quite different. Java's syntax is much more verbose, both explicit and strict. Transitioning from Python to Java has a lot to do with learning the new syntax. Java and Python are also different in that Java is compiled and Python is interpreted. This allows Java to run much faster and more efficiently. It also allows your Java code to be inspected for all kinds of errors, including syntax errors, type errors, and non-existent functions. When Java is compiled, it's converted to binary machine code or Java bytecode. This allows Java programs to be portable and run on different machines and operating systems. Compiled languages have many advantages over interpreted languages. When code is compiled, it's optimized under the hood. Since your program will be inspected for errors, many kinds of potential bugs will be caught early on. For example, using the same variable name twice. And your program will not run if it's not compiled. The IDE we'll be using for Java development, Eclipse, will compile your code for you on the fly as you save your work. It will also help you fix many problems in your code. The TIOBE Programming Community Index is an indicator of the popularity of programming languages. It can be used to check whether your programming skills are up to date or to make a decision about what programming languages to use when starting new projects. The ratings are based on the number of skilled engineers worldwide, courses and third-party vendors, and calculated based on popular search engines. The index is updated once a month. Here are the top 10 programming languages from a recent snapshot of the TIOBE Index. In terms of general highlights, Java is the most popular programming language, in first place. Python is in third place and is becoming more and more popular. Go to this URL for the most recent index. In order to use Java, you need to first install the Java Development Kit, or JDK. This is the package of tools for developing Java-based software. You'll also need the Java Runtime Environment, or JRE, which includes the Java Virtual Machine, or JVM. This is the environment for running Java applications. The JVM is what actually runs compiled Java bytecode. Go here to download and install the JDK, which includes the JRE and JVM. To download and install the JDK, locate the main download link. Then download the latest version of the JDK for your OS. Eclipse is one of the most popular IDEs for Java development. Another good one is IntelliJ. In this course, we'll work with Eclipse, so please use it. Eclipse makes it very easy to write well-formatted Java with good style. Like Python's PyCharm, it has a ton of features. It compiles code on the fly, provides autocomplete suggestions, and fixes simple bugs. Overall, Eclipse greatly speeds up Java programming. Go here to download Eclipse. Scroll down to get the latest version, then click the link to download the correct version of the IDE for your OS. When you extract and run the Eclipse installer, choose Eclipse IDE for Java developers. When you launch Eclipse, you should pick the default workspace option, unless you have a good reason to change it. Click Launch. Eclipse stores and manages projects in the workspace. When you use Eclipse to create a project, a single program, it creates a directory with that name in your workspace. Within the project, you create an optional package or subdirectory. Finally, within the package, you create a class or a file. For the simplest program, you'll only need a single package or the default no package, and only one or very few classes. Java is object-oriented and class-based, which means you have to create at least one class to write a Java program. Here's a very simple Java program. At the top, there's an optional package declaration. It should begin with a lowercase letter and use camel case, which means each word in the middle of the phrase begins with a capital letter. Then we have the class declaration. It should begin with a capital letter and also use camel case. The Java file will be named and saved in mypackage/myclass.java. Inside of the class definition, we have the main method, the starting point of any Java program. In Java, the name main is special and reserved for the main method. Like in Python, the main method in Java serves as the entry point to your program. Here are some general rules for Java. Individual statements end in a semicolon. New lines don't mean anything in Java. This means you could have an entire program on one line, but obviously, this is bad style. For example, here's a statement, printing to the console. It ends with a semicolon. And here's another statement, defining a variable. It also ends with a semicolon. Indentation doesn't matter. Unlike Python, where it's required, indentation in Java is a matter of style. While it won't make your program fail the way it does in Python, you should not stop indenting your programs. Thankfully, Eclipse helps you easily take care of the formatting of your code. You can use these shortcuts in Eclipse. This fixes the format of your code. And this selects all of the code in the Java file and fixes the indentation. Java uses curly braces to surround code blocks, unlike Python, which uses a colon and indentation to indicate code blocks. For example, here's a conditional, and here's a function. For purposes of style, an opening brace should go at the end of a line, not on a line by itself. You typically name variables using camel case, starting with a lowercase letter. Again, camel case means each word in the middle of the phrase begins with a capital letter. Every variable in Java has a predefined type, and you declare the type in front of the variable. Here, my int can only store an int. You must store that kind of data in the variable. For example, you can't do this and try to store a string in a variable defined as an int. Eclipse won't even let you compile your code. The type of a variable cannot be changed. This is because Java is statically typed. In Python, you can change variable types on the fly because it's dynamically typed. Here are some primitive or simple data types. Int is an integer. Float is a floating point number or decimal. Boolean is a true-false value. Here are some other primitive data types. A char is a single character. A double is a large and more precise floating point number. Byte, short, and long all refer to different integer sizes. Another data type is string, which is an object, not a primitive. It's used to store a character string. You might also come across class names like integer, boolean, or double. Don't worry about these for now. They're wrapper classes for the primitive data types. You can declare variables with initial values. Here we define a variable count of type int with an initial value of 0. And here we define a variable first name of type string with an initial value of Brandon. You can also declare variables without initial values. This declares a variable distance of type double without actually creating a double. And this declares a variable color of type string without actually creating a string. And then, of course, we can set the variables later in our code. Here we give the variable distance a double value, and we give the variable color a string value. In Java, there's a difference between a single character and a character string. Unlike Python, be careful about when you're using double quotes versus single quotes. To define a string, we use double quotes. Here, Brandon is a string. To define a char, use single quotes. Here, A is a char. Just like in Python, you can concatenate strings using the plus operator. Here we concatenate multiple strings and store the result in a string variable full name. Unlike Python, in Java, anything concatenated with a string is automatically converted to a string. For example, here we concatenate strings and numerical variables and store the result in a string variable, myResult. Note the difference with Python, where you have to cast non-strings to strings. There are two methods you can use for printing. This prints something and ends the line. And this prints something and doesn't end the line, so the next thing you print will go on the same line. These methods will print any one thing, but only one thing at a time. Of course, you can always concatenate strings with the plus operator. While loops in Java have a similar syntax to while loops in Python. Here's a simple while loop that iterates 10 times. I is initially set to 0, I must be less than 10 in order to enter the loop each time, and code in the loop manually increments I by 1 at the end of each loop. For loops in Java have a very different syntax than for loops in Python, but they are equivalent to iterating over a range. A for loop has 3 parts: setting the initial value, the condition for entering the loop, and the change in the loop variable that happens at the end of each loop. Here's a simple for loop that iterates 10 times. I is initially set to 0, I must be less than 10 in order to enter the loop each time, and I is incremented by 1 at the end of each loop, but you can't actually see it. To get input from the user, first import the scanner class. Then create a scanner and assign it to a variable. Here, the name of the scanner is scan, and calling new scanner tells Java to make a new one. System.in tells Java that the scanner is to take input from the keyboard. To read in the next int, call the nextInt method of the scan object. To read in the next string, call the next method of the scan object. To read in the entire next line as a string, call the next line method of the scan object. Here's a single line comment using double slashes. Here's a block comment using /* and */. As a shortcut in Eclipse, you can type the following: /* and then hit enter. Eclipse will add a block comment and you can fill in the rest. You can add Java docs or Java documentation just before the definition of a variable, method, or class. This is the equivalent of a doc string inside of a Python function or class. As a shortcut, you can type the following right above a variable, method, or class name. Eclipse will add a Java doc block and you can fill in the rest. In this Java doc, we describe the method as returning the sum of 2 given numbers. The first parameter, preceded by the param tag, is firstNum and is described as the first value to add. The second parameter, also preceded by the param tag, is secondNum and is described as the second value to add. Finally, the method returns a value, so the Java doc includes the return tag and describes the return value as the sum of values.
To create a project in Java, in Eclipse, go to File, New, Java Project, and then provide a project name. Project names should be capitalized. You can use the default location, which is your workspace, and use the default JRE and project layout. Then click Next. Make sure Create Module Info.java file is unchecked. You can use the default output folder. Then click Finish. The project will appear in the Package Explorer on the left-hand side in the IDE. To create a Java class in your Java project, go to File, New, Class, and then provide a class name. Class names should be capitalized. Make sure public static void main is checked and uncheck inherited abstract methods. Click Finish. You'll see your class file open up. Inside of the class, you'll see the main method. The entry point of any Java program is in the main method. Let's start by printing to the console. So I'm going to use system.out.println, and then I'm going to provide something to print, hello world. And then I'm going to end the Java statement with a semicolon. let's add a comment. Printing using SOPL, which is short for system.out.println. To run your Java program in Eclipse, go to Run, or you could click the Run button. You'll see the output in the console at the bottom of Eclipse. After printing Hello World, let's print a blank line. System.out.println with no argument, we'll print a blank line. Print a blank line. And then we're going to define some variables. I'm first going to add a multi-line comment. So I'm going to click /* return. Eclipse will automatically create a multi-line comment block. And I'll type defining variables. And I'm going to define an int. Int x, x is the name of the variable of type int, and set that to 5, followed by a semicolon to end the statement. Let's also define a double. Double y equals 5.0, semicolon. And then a Boolean. Boolean, we'll call it flag, and we'll set that to true. Now let's print the values of these variables. System.out.println will print the value of x. In Java, you can concatenate strings to non-strings. So let's concatenate the string x with the value of x, which is an int. And then we'll do the same for y. And we'll do the same for flag. Save, run my file, and I see my output here. X is 5, y is 5.0, and flag is true. Let's talk about casting from one data type to another in Java. Casting. I'm going to start by showing you how to cast an int to a string. Cast int to string. I'm going to create a variable of type string. I'll call it int to string. And I'm going to cast the number 1 to a string. To do that, I'm going to use the integer class. From that class, I'm going to use the toString method. And as an argument, I'm going to pass 1. The toString method will cast the given int, in this case 1, to a string. And I'm going to store that in the variable int to string. If I run my code, I could see that it was successful. And now I have a string version of the number 1. Now, how do I cast a double to a string? Well, it's very similar. Cast double to string. Again, I'm going to create a variable of type string. I'll call it double to string. And I'm going to cast 1.1 to a string. To do that, I'm going to use the double class. Within that class, there's a toString method. I'll provide the argument, in this case, a double, 1.1, and the toString will return a string version of 1.1, and it'll store it in the variable double to string. If I run my code, I could see that it was successful, so I now have a string version of 1.1. So how do I know that these values were successfully casted? Well, I know because the data type of these variables is string, and my code worked, so I know that these variables, which are strings, are storing string versions of the given values. But just to prove my point, let's go ahead and print the values and the type of the values. So we'll start with int to string. We're going to print the values and type of values. Before we print any values, let's just print a blank line. System.out.println with no argument. That will be my blank line. And then I'm going to print into string. So say system.out.println into string, and then concatenated with that, I'm going to print the type of that variable, or the class as it's known in Java. So into string dot get class. This is the equivalent of Python's type method. Go ahead and run this, and I could see that the value is 1, and the class, or the type, is java.lang.string. So the type of the value is a string. And then I'm going to do the same thing for double to string. So I'll copy this, I'll paste it here. I'm going to print double to string, and then I'm going to print the class or the type of double to string. Save it, run my code. I can see that the value itself is 1.1, and the class or the type is java.lang.string. So the type of this value is a string. Now we're going to go the other way, and I'm going to show you how to cast a string to an int. Cast string to int. I'm going to start by creating a variable of type int. We'll call it string to int. And again, I'm going to use the integer class, and within that class, I'm going to use the parseInt method. I'm going to provide as an argument the string 1. ParseInt will parse the given string into an int, and I'll store that in the variable string to int. If I run my code, I can see that it was successful, and this now stores an int version of the given string. Now, what if I want to cast a string to a double? Well, it's very similar. Cast string to double. So we'll start by creating a variable of type double. We'll call it string to double. And in this case, I'm going to use the double class. And then within that class, I'm going to use the parse double method. And I'll provide the string that I want to parse to a double, in this case, 1.1, as a string. Parse double will parse the given string into a double, and we'll store it in this variable, string to double. If I run my code, it was successful, and now I have a double version of the given string. Now let's print the values and the type of the values. Print values and type of values. Let's start with string to int. Printing the value itself is pretty easy. System.out.println string to int. If I go ahead and run my code, I can see that the value itself is 1. This is to be expected, but printing the type of that value is not as straightforward. String to int is a primitive value, so it's not an object, which means it doesn't have a getClass method. So first we need to cast to a generic object, then call the getClass method. So cast to object, then call getClass method. So we'll start with the system.out.println, and then I'm going to cast the primitive to an object. To do that, I can put object in parentheses, and then provide the primitive value that I want to cast, string to int, and then put this entire casted object in parentheses, then call the getClass method, and that should provide the type of the object. Run my code. I could see that the value is 1, and the class or the type is java.lang.integer, which is an int. Then we'll do the same thing for string to double. So I'm going to go ahead and copy this, paste it here. I'm going to first print the value stored in the variable string to double, and then I'm going to cast it to an object, call the getClass method that will provide the class or the type. Run our code. The value is 1.1, and the class or the type is java.lang.double, which is a double. Let's look at getting user input. To get input, I'm going to use the scanner class. So I'm going to create a new variable of type scanner. We'll call it scan. And And then I'm going to create a new scanner, which is creating a new instance of that class scanner. And I'm going to get input from the keyboard, which is system.in. The scanner class requires an import in my class file. So I'm going to put my mouse over the red squiggly line. I'll let Eclipse take care of this for me, and I'll click Import Scanner from java.util. Make sure you click the right one. Now if I look at the top of my file, I can see that Eclipse put an import statement, import java.util.scanner. Now I can use that class in my program. The first thing we're going to do is ask the user to input a number. System.out.println, enter a number. And then I'm going to get the next input value as an int. So scan.nextInt, get the next value as an int. Change that to nextInt. And then store the result in a variable of type int. We'll call it myInt. Get next input as int. Then let's just print that number. So system.out.println, your number is myInt. Let's run our code. Enter a number, 34. Your number is 34. Now we're going to print the multiplication table up to 10 from myInt. Print the multiplication table up to 10 for myInt. To do that, I'm going to use a for loop, which has 3 parts. So for, first you initialize your variable, int t, we'll call it t, equals 1. Then you create the condition for entering the loop, t equals less than 11. And then you increment your value each time the loop runs. So t plus plus. Each time the loop runs, I'm going to print the result of t multiplied by myInt. So system.out.println, I'm going to print the value of t concatenated with the x character, concatenated with myInt, concatenated with a colon, and then concatenated with the multiplication itself. So t times myInt. Let's also put a line break here, system.out.println. Again, this is a blank line. Now if I run my code, I can see enter a number, 4, and I can see the multiplication table up to 10 from myInt. 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, so on and so forth. So let's go ahead and prompt the user to enter a string. Enter a string. Let's go ahead and just print a blank line above that. Then I'm going to get the next input value as a string. So scan.next, just the next method, gets the next input as a string. Store that in a variable. String myString equals scan.next, get next input value as string. Then I'm going to print each character in my string separately. Print each char in my string separately. To do that, I'm going to use a for loop, which has 3 parts. For, and then you initialize your variable first, int u equals 0. And then the condition for entering the loop, as long as u is less than my string dot length, as long as u is less than the length of my string. And then I'm going to change u. I'm going to increment u within each iteration of the loop. And here I'm going to print the character at index u. Print char at index u. So system.out.println. I'm going to print my string, and then I'm going to get the character at the index u. Char at, this will actually return a char at index u, and print it. If I run my code, let's see, enter a number. This is our first question. There's the multiplication table. Enter a string, Brandon, and then it prints each character at each location in the string. The last thing we want to do when we're done is close our scanner. Scan.close. You should always add Java docs to class, method, and variable definitions. We'll eventually learn that Java docs are useful for easily creating documentation for an entire program. This can be extremely helpful for other programmers who are reading or running your code. Let's go ahead and add Java docs to our program. Only a couple places. Here at the top for my class definition, /**, return. I'll let Eclipse create the Java doc block for me, and then I'll fill in the information. My first Java class. And then it auto-populates the author. That's me. Now let's add a Java doc to the main method, which is the only method in my first class. /**, return. I'll let Eclipse create the Java doc block for me. This is the main method, the entry point to any Java program.
Everything in Java is object-oriented and class-based. This means you have to create at least one class to write a Java program. A class describes an object. It's like a template for a new kind of object. When you define a class, you're defining a new data type. To use the object, you create an instance of the class. It's a very similar concept in Python. A class includes fields or instance variables that hold the data for each object, constructors that describe how to create a new object instance of the class, and methods that describe the actions the object can perform. Here's simple syntax for defining a sample class. Public is an access modifier that defines the visibility of the class. Public means any other program in the Java project can use the class, i.e., create instances or call methods. We'll talk about other access modifiers later in the course. This class will contain fields, a constructor, and methods. These can be in any order. An object's data is stored in fields or instance variables. The fields describe the state of the object. Fields are defined as variable declarations in the class. Here's a sample class definition with instance variables. We've defined a variable name to store a string in the object, a variable health to store a double in the object, and a variable age to store an int in the object. Age is initially set to 0. Fields are available throughout the entire class that declares them. A constructor is code to create an object. The syntax for a constructor looks like this. Public means the constructor is accessible by any other program in the Java project. Class name has to be the same name as the class that the constructor occurs in. The constructor parameters are a comma-separated list of variable declarations. Here's a sample class definition with a constructor. A method is a function in an object that allows you to use and communicate with that object. The syntax for a method looks like this. If a method is to return a result, return type is the data type of the result. You must use a return statement to exit the method with a result of the correct type. If a method doesn't return a result, return type is void. This indicates that a method doesn't return a value. In this case, you don't need to use a return statement to exit the method. Here's a sample class definition with a method. The method is called getName, and it returns the value of the name instance variable. This refers to this instance of the class. To use a class, you create an instance of the object by calling its constructor and using the keyword new. Here's syntax to define a class and create an instance of that class. Notice we're starting in the main method, which is the entry point to our program. We create a new instance of the class className by using the new keyword and storing the instance of the class in a variable C. You have to test your code to get it working. You can do ad hoc testing by testing whatever occurs to you at the moment. For example, calling random methods with different inputs from your main method and printing and comparing the results, or running your program and trying different inputs for a scanner. Or you can write a set of unit tests that can be run at any time. This will always test your code in the same ways. It's just like the testing class we write to test our main program in Python. One disadvantage of writing unit tests is that it requires extra programming. This is true, but use of a good testing framework can help with the process. You might think that you don't have the time to do the extra work. This is not true. Testing reduces debugging time more than the amount of time spent building the actual tests. One advantage of writing unit tests is that it's almost guaranteed that your program will have fewer bugs. Another advantage is that it will be a lot easier to maintain and modify your program. This is a huge win for programs that get actual use in production. JUnit is a Java framework for writing unit tests. JUnit uses Java's reflection capabilities, which allows Java programs to examine their own code. JUnit helps the programmer define and execute tests, formalize requirements and clarify program architecture, write and debug code, and integrate code, and to always be ready to release a working version. A unit test tests the units or methods in a single class. A test case tests the response of a single unit or method to a particular set of inputs. You can and should have multiple test cases for a single unit test method. An integration test is a test of how well classes and methods work together. Integration testing that it all works together, is not well supported by JUnit, and we won't cover this. The unit testing process looks something like this. Call the method being tested in your program and get the actual result. Assert what the correct result should be with one of the assert methods. Repeat steps as many times as necessary. An assert method is a JUnit method that performs a test and throws an assertion error if the test fails. JUnit catches these errors and shows you the result. Here are some assert methods. Assert true asserts that a given Boolean value or condition is true. This version of assert true asserts that a given Boolean value or condition is true, and if it's not, it prints the given custom error message. Assert methods throw an assertion error if a particular test fails. If provided, the optional message is included in the error. Assert false asserts that a given Boolean value or condition is false. This version of assert false asserts that a given Boolean value or condition is false, and if it's not, it prints the given custom error message. Again, assert methods throw an assertion error if a particular test fails. If provided, the optional message is included in the error. In Java, you use the equality operator or double equal sign to compare primitives. For example, here we're comparing two ints, which are primitive values. The variable e will store the Boolean result of 2 equals to 3. You use the equals method to compare objects. In this example, we're comparing two strings, which are objects. The variable e will store the Boolean result of this string equals to that string. As a rule, when comparing a literal string value, a known string value, to an unknown string value, use the equals method of the known value. For example, here, the variable e will be set to true if the literal string value, this string, is equal to the string value stored in the some unknown string variable. Why do we do it like this? Because we know at least that this string exists and is not null, so it must have an equals method. On the other hand, the value stored in the some unknown string variable could be null, in which case calling its equals method will return an error. So why is all of this important? The JUnit method assert equals uses the equality operator to compare primitives and the equals method to compare objects. To define what equals means for your own objects, you'll have to implement the equals method. This means you'll have to define exactly this method in your class. The argument to the equals method must be of type object, which isn't exactly what you want, so you'll have to cast it to the correct type. For example, person.
Let's unit test our previous banking project. If you recall, our banking project had three classes. We had a bank class, which represented a bank, a customer class, which represented a customer, and a bank account class, which represented a bank account for a customer. Before we add unit testing files, let's go ahead and make some updates to the bank account class. So I'm going to open up the bank account class, banking project, source folder, banking package, bank account class, and I'm going to add an additional instance variable here. It's going to be called fast cash amount, and it's a double. And it's going to represent a fixed amount for quick withdrawals. Next, I'm going to update the constructor for the bank account class to set an initial default value for the fast cash amount. This dot fast cash amount equals 60. We'll set it to 60 initially. Set initial default value for fast cash amount. Next, I'm going to add an additional method. It's going to be called fast withdraw. And this is going to allow me to make a fast or quick withdrawal in the amount of the fast cash amount. So public void fast withdraw. And all this method is going to do is call our other withdraw method that we've already written with the fast cash amount. This dot withdraw, so call the withdraw method in the bank account class with the this fast cash amount. Withdraw the given fast cash amount. And because our withdraw method throws an exception if the given amount is greater than the available balance, we have to handle that exception in one of two ways. We can either put it inside of a try-catch, or we can just throw the exception. So let's do that. I'm going to go here, unhandled exception type exception, add throws declaration, and now we'll just throw the exception from this method as well. Let's document this method. Withdraws the fast cash amount, throws exception if given fast cash amount is greater than available balance. Now I'm going to write a method that will allow me to reset the fast cash amount. Public void set fast cash amount. We'll have to provide it with an amount, double amount, and then we're just going to set the fast cache amount. So this dot fast cache amount equals the given amount. Let's also check to make sure that the given amount is greater than 0. So we can't provide it with a negative value. So if the given amount is greater than 0, then reset the fast cache amount. So it sets the fast cache amount if greater than 0, amount to set as fast cache. Let's make a similar update to our deposit method so that it doesn't allow us to deposit a negative amount. So if the given amount is greater than 0, then deposit the amount. Deposit the given amount if greater than 0. Now we're ready to test our program. The first testing class I'm going to add is the customer test class because I'm going to test my customer class. File, new, JUnit test case. The name of the testing file will be customer test. I'm going to add the setup method. Click next. What are the methods that I want to test? Just the set address method. Create tasks for generated test methods, and finish. I have to add the JUnit 5 library to the build path. Click OK, and we're ready to start adding our test cases. In order to test methods in the customer class, I need to create an instance of the customer class. So let's define a customer up here. Customer, and then I'll initialize the customer inside of the setup method, which is run before every test method. This .customer equals new customer. When I create a customer, I have to provide a name for the customer. Brandon. So let's declare customer for testing, and then we'll initialize customer here. Then I can write my test cases using that customer object. Before we test the set address, let's confirm what the value of the address is before we set it. So I'm going to start by using assert null. The address should be null to start. So this .customer.getAddress, which will return the current address, it should be null. And the reason that's true is if I open the customer class, I've defined the address here as an instance variable with no initial value, and I don't set it in the constructor. So it should be null by default. Assert null, this.customer.getAddress confirms the initial value of address is null. Now let's set the address for the customer and then retest. This.customer.setAddress, we'll set it to Brooklyn, New York. Sets address for customer. Then let's retest to confirm that the address was set correctly. Assert equals, what I'm expecting to get is Brooklyn, New York. When I call this .customer.getAddress, I want to check that the address was set correctly. Checks that address was set correctly. Then let's run our test. Green, which means success. The address was set correctly after calling setAddress. Let's test it again by resetting it and then asserting that it is what it should be. This.customer.setAddress. I'll set it to Cranston, Rhode Island. Reset address for customer. And then assert equals, I'm expecting to get Cranston, Rhode Island. When I call this .customer.getAddress, checks that address was reset correctly. Let's rerun our test. Still green. It looks like the setAddress method is working as it should. Now let's test the bank account class. I go back to the Package Explorer, select Bank Account, File, New, JUnit Test Case. It'll be called Bank Account Test. We'll add the setup method. The methods that I want to test are deposit, withdraw, fast withdraw. Click Finish. To test methods in the bank account class, I need to create some instances of the bank account class. So let's define those up here. Bank account, we'll call it my checking account. And we'll create another one, bank account, my savings account. In order to create a bank account, I actually need an instance of the customer class. Customer, declare objects for testing. Then let's initialize the objects here in the setup method. This.customer equals new customer with a name. This.my checking account equals new bank account. The first argument is the type of bank account, checking. Second argument is the customer for that account. That'll be this.customer. And then let's initialize the savings account. This.my savings account equals new bank account. The type is savings. The customer is the same customer. Initialize objects here for testing. Let's start by testing the deposit method. We'll first deposit a certain amount of money into one of the accounts. We'll use the checking account. And then we'll assert what the current balance should be. Make deposit. This.my checking account dot deposit. Let's do $100. And then let's assert that the balance is $100. So assert equals, I'm expecting to get 100 if I get the current balance of the checking account. This.my checking account dot balance. Test that current balance is 100. Now let's run our test. I can see that the test deposit method is passing all of its unit tests. Let's add some additional tests. What happens when I try to deposit a negative amount, which the deposit method should not allow me to do? Make deposit of negative amount. So this dot my checking account dot deposit. And let's try to deposit negative 100. Since I've written the deposit method to ignore negative amounts, the balance should be the same. Assert equals, I'm expecting 100 when I get the balance. This dot my checking account dot balance. Balance should be the same. Rerun our tests. Test deposit, still passing all of its unit tests. And just for fun, let's add one more test. Let's try to deposit $0. This.my checking account, deposit 0, deposit 0. And of course the balance should be the same. Assert equals 100. Rerun our tests. Test deposit, still passing all of its unit tests. Now let's test the withdraw method. To do that, we have to make an initial deposit into one of the accounts so we have something to withdraw. So let's use the savings account and make a deposit. this.mysavingsaccount, deposit. Let's deposit $100 to start. Deposit initial 100 into savings. Just for fun, let's test the balance. Assert equals 100 this.mysavingsaccount. Get the balance. Assert current balance. Let's run our tests. Looks like test withdraw is now passing its tests. Let's try to make a withdrawal. This.mysavingsaccount.withdraw. We'll try to withdraw $80. Notice I'm getting an error here because the withdraw method throws an exception. If I look back at my bank account class, I recall that withdraw throws a possible exception if the given amount is greater than the available balance. So here, since I'm calling that method, I have to handle it. I can do that in one of two ways. Either put it inside of a try-catch or throw it. In this case, I really want to handle it and put it inside of a try-catch. Surround with try-catch. So try to make withdrawal of 80. I should be successful. So then when we test the balance, it should be 20. Assert equals 20. This.mysavingsaccount. Get the balance. Balance should be 20. Let's run the test. Test withdraw, still working. Now let's try to withdraw an amount that we know is greater than the available balance. Try to withdraw amount greater than available balance. And I'm going to expect an exception. And why is that? Because the withdraw method, again, throws an exception if the given amount is greater than the available balance. So I'm going to expect an exception in this case. The way we test for that is by using assert throws. Assert throws. I'm expecting an exception dot class when I run the following code. This.mysavingsaccount dot withdraw $21. Using assert throws, I'm expecting an exception when I run the code this.mysavingsaccount.withdraw $21 because it's more than the available balance. In this case, it should not withdraw the amount, and the balance should remain the same. Assert equals, balance should still be 20. This.mysavingsaccount balance. Balance should be the same. Run the test. Still passes. The opposite of assert throws is assert does not throw. So if I want to test that a particular block of code does not throw an exception, I can use assert does not throw. So try to make withdrawal does not throw exception. Assert does not throw. No exception is expected when I run the following code. This.mysavingsaccount withdraw $19. Should have an available balance there. And the remaining balance should be $1. Copy this, paste it here. Balance should be 1. Assert equals 1. Rerun the test. Test withdraw, still working. And finally, let's test the fast withdraw method. The process here will be similar to testing the withdraw method. So let's make an initial deposit into one of the accounts. this.my checking account. Deposit, $100. Initial deposit. And we'll try to make a fast withdrawal. This.my checking. And we'll do fast withdraw. We're getting an error here because similar to the withdraw method, the fast withdraw method throws a possible exception. So let's go ahead and catch that. So try to make fast withdrawal. By default, default amount is $60. So that should work. And then we can check our balance, which should be 40. Assert equals, I'm expecting 40. Checking, get the balance. Balance should be 40. Run our tests. All tests are passing now, including this one. Now let's reset the fast cash amount and then try to make another fast withdrawal. So this.my checking account, set fast cash amount. Let's change the default to 20. Amount to 20, and then try to make a withdrawal. If I try to make a fast cash withdrawal, I'm not expecting an exception, so assert does not throw. I'm not going to get an exception when I run the following code. This.my checking account dot fast withdraw. Should have available balance there, and then the new balance should be 20. Check balance, assert equals, I'm expecting 20. Get the balance. And this is assert that an exception is not thrown when I make fast cash withdrawal. Let's run our test. Everything is still passing. Now let's try to reset the fast cash amount to a negative value, which should be ignored. Set fast cash amount to negative value should be ignored. Set fast cash amount, negative 50, should not work. Fast cash amount should still be 20, which we set here. So now if I try to make another fast cash withdrawal, it should withdraw $20. So this, my checking account, fast withdraw should still withdraw 20. Of course, I have to handle the possible exception. So run with a try catch. And our current balance should be 0. Expecting 0. Balance should be 0 after fast withdrawal. Now I'm going to try to make one more fast withdrawal. Note, my account balance is $0, so this should throw an exception. Let's test for that. Assert throws. I'm expecting an exception when the following code is run. I try to make a fast withdrawal. Again, expecting exception when I try to make fast withdrawal because of 0 balance. Let's run our tests one last time. All tests have passed. We'll clean up our file. And we're done.
An array is a way to store a collection of items as a single unit. It's like a list in Python, but not exactly. Arrays are defined with a fixed number of slots, each of which holds an individual item, and you can add and delete items from those slots as needed. Each item in an array is distinguished by a numerical index between 0 and the array size minus 1. This works exactly the same as list indexing in Python. Arrays can contain any type of element value, primitive types or objects, but you can't store different types in a single array. You can have an array of ints, an array of strings, or even an array of arrays, but you can't have an array that contains, for example, both strings and ints. An array itself is an object. To create an array in Java, you first declare a variable to hold the array. Array variables indicate the type of object the array will hold, followed by empty brackets and the name of the array. For example, this declares an array of ints, and this declares an array of strings. Imagine we have a customer class. This declares an array of customers. The second step is to create an array object and assign it to that variable. There are two ways to do this. One way is to use the new operator to create a new instance of an array. This creates a new array of strings with 10 slots, sometimes called elements. When you create an array object using new, you must indicate how many slots that array will hold inside the brackets. This does not put actual string values in the slots. You'll have to do that later. This creates a new array of ints with 99 slots. The third step is to store things in the array. You can access the value in any slot of an array by specifying the index number inside brackets. Again, this works exactly the same as list indexing in Python. Remember, indexing starts at 0. This creates an array of 3 doubles, and then sets the individual values by using an index number inside brackets. We set the first value in the array to 5.0 using index 0. We set the second value in the array to 4.1 using index 1. And we set the third value in the array to 3.9 using index 2. This creates an array of 2 booleans, and then sets the individual values. Note, if you use an index outside of 0 up to myArray.length minus 1, you'll get an array index out of bounds exception. Another way to create an array is to enclose the elements of the array inside curly braces, separated by commas. This initializes the contents or values of the array in the array declaration. For example, this creates an array of ints with actual prime numbers. And this creates an array of strings with actual programming languages. Imagine we have a customer class. This creates an array of customers with actual customers. The syntax above can only be used in the array declaration. You can't do this. Every array has a length variable that tells how large the array is. This array of ints has a length of 10. And this array of customers has a length of 2. Note, length is an instance variable, not a method. On the other hand, strings have a length method. Arrays cannot be easily resized. You'd have to create a new array, copy everything from the old array, and add the new elements to the new array. You can use a for loop to visit and/or set every element in an array using its index. Here we iterate over an array using its length, where I represents the index of each item. The name I is traditional for loops. I is instantly recognizable as the index of an enclosing for loop. Note, inner or nested loops typically use J, then K. Use of length is always preferred over using a constant or hard-coded value, such as 10. Try not to do this. You can also use an enhanced for loop to visit every element in an array. This is like the for-x in list syntax in Python. Here we iterate over an array of strings, where n represents each item in the array. This simple structure allows you to visit each element of an array without explicitly expressing how to go from element to element using an index. Elements of an array can be arrays themselves. The following creates an array of 3 arrays, each of which points to an array of 2 ints. Then it populates each slot in the array with an incremented count. The first for loop iterates over the rows in the array. The nested for loop iterates over the columns in each row and sets each slot to an incremented number. This is like a table with 3 rows and 2 columns, where the length of the table is 3 and the length of each row is 2. This is the same as defining and directly populating a 2-dimensional array like so. Each array has 2 elements. To compare 2 nested arrays, you can use the arrays.deep_equals method to do a deep comparison. Table and table2 have the same values. You can also have non-rectangular arrays. Here we update the 3rd element in the array to point to an array of 20 ints. This is the same as initializing a 2-dimensional array like so. The first 2 arrays have 2 elements, and the 3rd array 20 elements. To access the value in any slot in a 2-dimensional array, specify the index number of the row inside brackets, followed by the index number of the column inside brackets. For example, to print the value in row 0 and column 0, you'd use table 2, followed by index 0 and index 0. This prints 1. To print the value in row 2 and column 2, you'd use table 2, followed by index 2 and index 2. This prints 0. An array list is like an array, but much more flexible. It's just like a list in Python. Array lists are not defined with a fixed number of slots. They have a variable length. Array lists can only contain objects, and you can't store different types in a single array list. Array lists are part of Java's collections framework. Collections are defined in java.util. To use array lists specifically, you have to import java.util.arraylist. All collections share similar methods, for example, add, remove, and size. We'll learn more about collections later in this course. The syntax to create an array list looks like this. You put the type of data being stored in the array list inside of angle brackets. You can't store primitive values in an array list, so you have to use the wrapper classes associated with the primitive types. For int, use integer. For double, use double, and so on and so forth. These are essentially the object versions of the primitive data types, with additional methods and attributes. This creates an array list of integers, and this creates an array list of strings. Every array list has a size method that tells how large the array list is. This array list of integers has a size of 3. We first create the array list, then add individual elements to the array list using the add method. Note, size is a method, not a variable. Array lists can be easily resized. You don't have to initialize array lists with a specific size. You can add or remove elements without worrying about it, and array lists will take care of the resizing for you. You can easily print primitive values in Java. This prints a is equal to 5. You know what to expect when you print a primitive. This prints b is equal to false. Printing objects is not as straightforward. What would you expect this to print? you need to tell Java what to print by defining the toString method in the class. This means you have to define exactly this method in your class. The toString method must return a string.
Let's implement the toString method in a customer class. File, New, Java Project, Customer Class Project, uncheck, click Finish. Going to create a customer class. File, New, Class, Customer. Click Finish. This will be a very simple class, just to demonstrate toString. Represents a customer. We'll have one instance variable. Just the name of the customer. I'll create a constructor. Public customer. It'll take one argument, the name of the customer, and then we'll set the instance variable name based on the given name. This.name equals the given name. Now I'm going to implement the toString method so that Java will know how to represent a customer as a string. I have to define the method exactly like this. Public string toString. Java is going to look for this method exactly when it tries to convert or represent a customer as a string. Of course, I have to return a string, but I can return any string I want. In this case, I'm going to return the name of the customer. Returns name of customer. Returns name of customer to be printed by Java. Now let's create a main method so that we can run our program and create instances of the customer class. Public static void main given a string array. Now if I create an instance of the customer class, I can easily represent that customer as a string. Customer C equals new customer. We'll give that customer a name, Brandon. And now let's print customer C. System.out.println C equals, and we'll concatenate customer C. This will try to convert customer C to a string. To do that, it's going to look for and call the toString method in the customer class by calling the toString method. Our toString method that we defined in the customer class happens to return the name of the customer. So when we run this, it's going to print C equals Brandon because the toString method returns Brandon.
So far, we've been defining variables as instance variables in our Java classes. Instance variables are just variables defined inside of a class, and every instance of a class can have a different value for an instance variable. In this module, we'll look at defining static variables in our Java classes. Static variables are also defined as variables inside of a class, but with the keyword static. Static variables have the same value for every instance of a class. In fact, you don't even need to create an instance of a class to use a static variable. We'll also look at static methods. And just like static variables, you don't need to create an instance of the class to use or call a static method. In this module, we're also going to introduce polymorphism, which refers to overloading and overriding. We'll focus on overloading, which is having two or more methods in the same class with the same name. In the next module, we'll look at overriding, as well as the concept of inheritance, the framework in which one class inherits the fields and methods of another class. Java classes can have instance variables and static variables. Instance variables can be different for every instance of a class. You define them as variables inside the class. In the class employee, we define an instance variable name, and we set the value of that name in the constructor. We call this.name equals name, which sets the value of the instance variable name in the class to the value of the given name in the constructor. You reference an instance variable using the instance of a class. If you create multiple instances of employee, every employee can have a different value for the name variable. Here we create two employees by calling the constructors with different names. If we access and print the value of each employee's name, we'll see they're different. This prints Brad, and this prints Sue. You need an instance of employee to access the name variable. Static variables are the same for every instance of a class. These are equivalent to class variables in a Python class. You define them as variables inside the class using the keyword static. You typically use all uppercase characters when defining static variables, separating syllables with underscores. They often refer to properties that are common to all instances of a class. In the class employee, we define a static variable department, and we set the value to accounting. You reference a static variable with a class name, not an instance of a class. Even if you create multiple instances of employee, every employee will have the same value for the static variable department. Here we create two employees by calling the constructors with different names. If we access and print the value of an employee's department, we'll see it's accounting. You actually don't need an instance of employee to access the static variable department. You reference the static variable using the full class name. Static variables are extremely useful for hard-coded values. These are values that should be the same for all instances of a class. For example, if a banking-related class utilizes a standard sales tax rate, it should be the same for every instance of that class. So you can declare it as static. Here in the bank account class, we declare a static variable sales tax and set the value to 0.06. This will be the same for every bank account or every instance of the bank account class. Remember, to access a static variable, reference the static variable using the full class name. Here in the purchase method, before deducting from the bank account's balance, we calculate the amount of sales tax by multiplying the given purchase amount by the standard sales tax rate. We access the static value by referencing bankaccount.salestax. If a static variable is never going to change, you can add the final keyword after static. Java classes can also have static methods. Just like static variables, you don't need to create an instance of a class to call a static method. For example, the math class has a static method square root. You don't create an instance of the math class to call square root. Instead, you use the class name to call the method. Oftentimes, Java helper methods are static. Helper methods are utility methods that assist a program in doing some basic error checking or processing of a given input. Here we have a class helper class with various helpful static methods for checking the validity of a number. To use this class, reference the class name to call a static method. Here we check if a particular number is valid by calling helperClass.isValid, which returns a Boolean value. The very first method we saw in Java was the static main method. Public static void main is the first method Java looks for when running a program. How does Java run the following program? It looks for a public static void main method in hello world and runs it without creating an instance of hello world. So when should we use a static method? When there's no need for the method to belong to an instance of the object. It could be as simple as the method doesn't need to access, manipulate, or store any data in an instance variable. As another example, in a class fraction, you might have a static method GCD, which returns the greatest common denominator of two given numbers. Do you need an instance of the fraction class in order to do this? No, you don't. So the method can be static. We know that static variables can be used for constant values. These are values that are the same for all instances of a class. Here, in the circle class, the instance method calculateArea needs the value of pi to calculate the area of a circle with a given radius. Pi is never going to change, so it's stored as a static final variable in the circle class, so the calculateArea method can access it. This is legal. As a rule, instance methods can access static variables. Another common usage is to use static variables to share data across instances of an object, for example, to keep track of the object instances created. Here in the main method, we create multiple instances of the car class. The constructor for the car class adds that instance of a car to a static array list, car list, stored in the car class itself. So every instance of car is stored in a static variable in the car class. We then iterate over the static array list to access and print each car. Here are some other rules for static. A static method can access only static variables. It cannot access instance variables. A static method can call another static method. An instance method can call a static method or access a static variable. And the keyword "this" does not make any sense inside of a static method. In any programming language, a signature is what distinguishes one function or method from another. In C, every function has to have a different name. In Java, two methods have to differ in their names or in the number or types or sequence of their parameters. For example, these are considered different. They have the same method names, but a different number of parameters. These are considered the same. They have the same method names and the same parameter, a single int. These are considered different. They have the same method names, but different parameters. In the first foo method, the parameters include an int followed by a double. In the second foo method, the parameters include a double followed by an int. In Java, a method signature does not include the return type. Polymorphism means many or poly, shapes, or morph. In Java, polymorphism often refers to the fact that you can have multiple methods with the same name in the same class. Polymorphism is divided into two types: overloading, which is having two or more methods with the same names but different signatures, and overriding, which is replacing an inherited method with another having the same signature. Here's a myPrinting utility class with two myPrint methods, each with a different parameter. The first myPrint method takes an int and prints it. The second myPrint method takes a double and prints that. So this method has the same name, but a different parameter. In the main method, we first create an instance of the myPrinting utility class. We then call the myPrint method with 5. Java will use the myPrint method designed to accept and print a given int. When we call the myPrint method with 5.0, Java will use the myPrint method designed to accept and print a given double. Why overload a method? So you can use the same names for methods that do essentially the same thing, but with different inputs. For example, there are multiple versions of the system.out.println method. It's been overloaded. These all take a single argument and print it. As another example, there are multiple versions of the assert equals method because it's been overloaded. These all take 2 arguments and compare them. Another reason to overload a method is so you can supply defaults for the parameters. In this myCounting utility class, we have an increment method that takes a given amount, increments the count instance variable, and returns the new count. Then we have another increment method that doesn't take an input at all. It increments the count instance variable by 1 by calling the first increment method with a default argument of 1 and returning the result. Another reason to overload a method is so you can supply additional information. In this myResults class, we have a printResults method that prints the values of the total and average instance variables. Then we have another printResults method that takes a given string message, prints it, and then calls the first printResults method. When you overload a method with another, very similar method, only one of them should do most of the work. In this myInformation class, we have a debug method that prints the first value, the last value, and information from the class's dictionary object. Then we have another debug method that takes a given string, prints it, and then calls the first debug method. Here, the first debug method does most of the debugging work of printing and iterating over the dictionary. The second debug method does something extra and then just asks the first debug method to do all of the other debugging work. In some cases, you can assign a different type of data to a predefined data type. Widening means going to a wider data type. Here we're assigning an int to a variable of type double. This is legal. Narrowing means going to a more narrow data type. Here we're assigning a double to a variable of type int. This is illegal. Unless, of course, you cast. Here, we're rounding a double and casting to an int, and then assigning to a variable of type int. This is legal. As a rule, all ints are doubles, but all doubles are not ints, unless, of course, you first cast. Method calls have the same rules. In the following myPrinting utility class, we have a single myPrint method that takes a given double and prints it. The following call to myPrint is legal due to widening. We first create an instance of the myPrinting utility class in the main method. Then we call the myPrint method with 5, which is an int. Because of widening, Java will convert 5 to 5.0 and print it. In this myPrinting utility class, we have a single myPrint method that takes a given int and prints it. The following call to myPrint is illegal due to narrowing. We first create an instance of the myPrinting utility class in the main method. Then we call the myPrint method with 5.0, which is a double. Java doesn't allow narrowing a double to an int, so this is illegal. If your methods are legally overloaded, Java will figure out which one you want to use. In this version of the myPrinting utility class, we have a static myPrint method that takes a given double and prints it. We also have a static myPrint method that takes a given int and prints that. In the main method, we call the static myPrint method with 5, which is an int. Java will look for a myPrint method that accepts an int and use that. We also call the static myPrint method with 5.0, which is a double, so Java will look for a myPrint method that accepts a double and use that.
You can overload constructors as well as methods. For an example, let's create a counter class with 2 constructors. First, let's create a new project. File, new, Java project. We'll call this counter class multiple constructors. Click next, uncheck this, click finish. Now let's create our counter class. Go here, file, new, class. We'll call it counter. Going to want a main method. Click finish. This class represents a counter. The counter class will have one instance variable, the internal count. Now let's create our constructors. Our first constructor will create a counter and start the internal count at a given start value. Public counter, and then we'll have one parameter, the initial start value. So this creates a counter and starts internal count at given start value. And then in here, we're just going to set the instance variable of count to the given start value. So here, I can create a counter. We'll say counter1 equals new counter, and we could start the count at any number we want to. So let's say 2. And just for fun, let's print the value of the count in that counter. So counter1 dot count. We run our program. We should see that the internal count is set to 2. Now, what if I want to create a counter in a different way? For example, I don't want to provide a start value. Well, I can do that by creating another constructor. So I can create another constructor, public counter, that takes no arguments. In this constructor, I'm going to set the internal count initially to 0. Creates a counter and starts internal count at 0. So one constructor overloads the other constructor. They have the same name, but a different number of parameters. And now I have another way of creating a counter. Counter2 equals new counter with no arguments. And of course, I can print the value of the internal count of this counter. Say counter2 count. I run the program. I'll see that the internal count by default is set to 0. So I have two ways of creating a counter. By simply creating two constructors, one overloads the other. If you overload constructors, one constructor can call another constructor in the same class. But there are some rules. You call the other constructor with the keyword this, and the call must be the very first thing the constructor does. To demonstrate, let's create a point class with two constructors. First, I'll create a project. File new, Java project, point class, multiple constructors. Uncheck, click finish. Now let's create a point class. We'll call it point, add a main method, and this class represents a point with x and y. We'll have just a few instance variables in this class. We'll have the x value for the point, we'll have the y value for the point, and then we'll have the sum of the two. So this is x for point, y for point, and sum of x and y. Now let's create the constructors. The first constructor for this class will take a given x and y and set the instance variables in the class and calculate the sum. So public point will take a given x and we'll take a given y and then set the instance variables in the class. So this dot x equals the given x, this dot y equals the given y, and then calculate the sum. This dot sum equals given x plus the given y. So this creates a point at the given x and y, x for point, y for point. So now I have a way of creating a point. I can do that in my main method. So say point1 equals new point at 2, 4. And let's print the x and y for that point. System.out.println. We'll print point1.x. Let's also print the y value and the sum. So this will be y, and this will be the sum. If we run our code, we can see that the x for the point is 2, the y for the point is 4, and the sum of the two is 6. Now, what if I want another way of creating a point without providing any arguments at all? Well, I can do that by creating another constructor. So I'm going to overload the constructor, public point, same name, but different parameters. In this case, no parameters. All this constructor is going to do is call the other constructor with some default values for x and y. To call another constructor in the same class, you use the keyword this, and then I have to provide the arguments. So I'm going to create a point by default at 0, 0. So this calls first constructor with default values 0 and 0. And we can say that this creates a point at 0, 0. So now I have another way of creating a point because I have a second constructor. So let's create another point using that second constructor. Point2 equals new point, no arguments. This should create a new point, and by default, the x and the y will be at 0. So let's print the values. System.out.println point2.x, and we'll print the y and the sum as well. Y, and then print the sum. Let's run our code. We could see that the x for point 2 is 0, the y for point 2 is 0, and of course the sum for point 2 is also 0. And so what do we have here? We have one constructor that overloads another constructor. The first constructor does all of the work. It sets the instance variables based on the given x and y and calculates the sum. And the second constructor calls the first constructor by using the keyword this and providing the necessary arguments, default values for x and y. In summary, as a rule, you should overload a method when you want to do essentially the same thing but with different parameters.